Hi everyone, I'm Robert Owens from the University of Tennessee at Chattanooga, and today I'm presenting a practical framework for reducing diesel emissions at music festivals by 60% using technology that's available right now. A major music festival burns over 100,000 gallons of diesel fuel in a single event. That produces over 1,000 tons of CO2. With more than 800 festivals worldwide, spending $4.2 million annually on fuel alone, the collective environmental and economic impact is enormous, and it's growing every year. These events are essentially temporary cities. They have medical facilities, food operations, camping for 100,000 people, massive sound systems, and stage lighting, all powered by rows of diesel generators deployed in fields with no grid connection. Peak demand reaches 3 to 5 megawatts, supplied by 50 or more generators per event. So the obvious question is, why not just replace those generators with battery energy storage? The technology exists, costs are coming down, so what's stopping us? The answer starts with professional audio. Festival sound systems have 3 non-negotiable requirements. First, total harmonic distortion must stay below 0.1%, and we notice distortion as low as 0.05%. Second, power must follow the instantaneous 10 to 15x current spikes within milliseconds. And third, the reference system, L-Acoustics L2, outputs 155 decibels. These 3 constraints define the entire power systems design. The core problem is the total harmonic distortion. Professional audio needs THD below 0.1%. In the best grid-forming inverters on the market, even 2 megawatt units designed for hospitals, deliver 1.8 to 2.3% THD under nonlinear loads. That's an 18 to 23x gap. This causes audible artifacts like buzzing and coloration that most anyone would think something sounded wrong, which also stresses the amplifier components greatly. And it's a fundamental electrical property of the inverter topology itself, and you cannot fix that with any software. But it gets worse. Electronic music in particular creates extreme transient loads. Bass drops produce current spikes 10 to 15 times above average, lasting 10 to 50 milliseconds. A 100 kilowatt audio system can demand 1.5 megawatts instantaneously. Inverter protection algorithms interpret these legitimate transients as fall conditions and completely shut down. The audio cuts out in the middle of the show. And on the other hand, diesel generators handle transients just fine through physics. Rotating mass provides instant power availability while the governors catch up. There's no software interpolation, no processing delay, but inverters don't have that luxury. The protection algorithms trip on current surges, and if you try to oversize the battery system to handle those spikes, you destroy the economics entirely. It just doesn't make sense. A festival needing 150 kilowatts of audio power would require 2.5 megawatts of battery and inverter capacity to handle those transient spikes. That's $2,500 a day for diesel versus $37,500 for BESS. It's a 15 to 1 cost ratio. So pure BESS for audio is economically dead on arrival. And this isn't theoretical. Every successful festival BESS deployment avoids powering audio through inverters. Glastonbury, the world's largest greenfield festival, used batteries for art installations, not audio. Portola achieved 96% diesel reduction but kept audio on traditional power. Luck Reunion cut diesel 90% for non-audio loads, and Higher Ground explicitly split their domains. So organizers are doing this, and the pattern is consistent. Batteries work well for everything except the stages. Which leads to the key insight of this paper. Not everything at a festival needs audio-grade power, and that changes everything. Analysis reveals that 40% of total festival load requires only standard commercial grade power quality, 3% THD or less, which today's inverters deliver just fine. Over 60% of the load, the audio, stage lighting, video, broadcast, needs the sub 0.1% THD that diesel naturally offers. The power quality requirements determine exactly which loads can shift to the battery. Here's the segmentation. BESS handles production village, premium camping, vendor operations, EV charging, water systems, and general lighting. All steady state, standard quality loads. Diesel continues supplying stage audio, stage lighting, video walls, and broadcast equipment. Each power source then operates within its optimal parameters. Load segmentation is the foundation of the hybrid architecture. Intelligent load segmentation, not wholesale replacement. The distributed architecture places a central BESS hub and local battery units near load centers throughout the festival grounds and site. Production, camping zones, and vendors, while diesel generators directly supply stage audio, lighting, and video. Automatic transfer switches, shown as ATS, provide failover at every site. Medical facilities get dual-fed power from both sources, never shed. The topology provides N+1 redundancy, reduced cable runs, and a very flexible deployment. The system operates in 3 modes. During normal operation, about 18 hours a day, BESS handles all suitable loads while diesel stays on standby, achieving the lowest emissions. During peak show hours, roughly 6 hours a day, diesel automatically starts for audio and stage loads while the BESS system continues to cover base loads. In an emergency, automatic transfer switches move everything to diesel until the BESS system can recover. Transitions are managed automatically by the building management system. The framework leverages L-Acoustic's next generation L2 system, which fundamentally changes the equation. Compared to legacy K1 arrays at equivalent audience sizes, L2 delivers 24.7 lower power consumption, 39.3 kilowatts versus 52.2, while producing 6 decibels higher SPL. So that's 4 times the acoustic power per watt with less electrical draw. 3 standardized configurations address festivals of any scale. Configuration A serves 10 to 20,000 attendees at just 26.7 kilowatts of audio power. Configuration B scales to 50,000, while C handles up to 100,000. All 3 delivered the same 155 decibel SPL output, they just differ only in BESS capacity and diesel backup sizing. For a Configuration B deployment, 35,000 attendees over 9 days, the hybrid system reduces diesel energy consumption from nearly 150,000 kilowatt hours to just under 59,000. Fuel drops from 42,000 liters to 16,000, and CO2 from 112,000 tons to 44. That's a 60.7% reduction across the board. And it pays for itself. The hybrid system costs $52,000 less per event than diesel only, even accounting for BESS rental. That's $1.50 less per attendee, a 67% internal rate of return without subsidies. Premium camping and EV charging create an additional upside that further offsets battery cost. Beyond economics, the hybrid approach reduces generator count by 70%, from 50 down to 15. It cuts noise in camping areas by 20 decibels, enabling silent nighttime operation. Setup time drops by 40% through pre-positioned BESS units, and 60% fewer cable runs means less copper and faster deployments. 3 takeaways. First, segment, don't replace. Don't try to eliminate all the diesel. Audio demands less than 0.1% THD that inverters simply can't deliver. Second, 40% of festival loads work on batteries today, achieving that 60% diesel reduction, $52,000 in savings, and 67% IRR. Third, this framework is deployable immediately with commercial equipment. There's no breakthroughs required. Future work includes machine learning for load forecasting, DC microgrids that could eliminate the THD issue entirely, and solid-state batteries expected by 2028 that may resolve the transient limitations. Thank you guys so much for your time. I'm Robert Owens. My email is on screen, or I'd love to connect with you on LinkedIn. Take care.